Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter chemical reactions, right? Now let's go for continuing this chapter. And remember, this is fourth period of this chapter. You all know that in yesterday's class we learned three important concepts. Can you recall them? Yes. First one is, it is balancing a chemical equation, right? For balancing purpose, we followed a method. What do you call that method? Yes, you are right. This is hit and trial method. Is it not? Then, second important concept, after balancing a chemical equation, we learned how to make it as more informative. Then, could you recall the points to be considered to make a chemical equation as more informative? Yes, one by one. First one is, it is by indicating the physical state of reactants as well as products. How do you go for that? Yes, if it is solid, we write yes. If it is liquid, we write L. If it is gas, we go for writing G. And sometimes even we go for using upward arrow mark. And what do you call the solution which is prepared by using water? Very good. It is aqueous and written as AQ. In that, if precipitate is formed, then we will go for writing, again it is solid, because precipitate is a solid which is obtained as a result of chemical reaction. And that precipitate will also be represented with the downward arrow mark. Is it done? Next, what is the another point to be considered to make a chemical equation as more informative? Yes, you are right. It is reaction condition. Is it not? Reaction. What are the reaction conditions? You all know that chemical reaction takes place under some conditions. Sometimes we have to provide the heat. Sometimes it takes place at particular temperature or at particular pressure in the presence of catalyst, in the presence of sunlight, by passing electricity. Is it not? So these are all the conditions. Got it? By indicating the reaction conditions, we can go for making it as more informative. And the third point, it is you can make a chemical equation as more informative by indicating the heat changes. Right? By indicating heat changes. That means when some chemical reaction takes place by absorbing the heat, and some chemical reaction that takes place and after the reaction they give out the heat, right? If the heat is absorbed, it is to be written on the left hand side of the equation, nothing but reactant side. If heat is given out, then heat is to be written on the right hand side of the equation, nothing but the product side. After writing all this, we recall the third important concept. What is that? The points to be considered while writing a chemical equation. Is it not? So these are the things that we had discussed in the last class. Now, in today's class, we are going to discuss about very important concept, that is types of chemical reactions. Yesterday only I had given you the brief introduction about this. You all know that during a chemical reaction many changes take place. Based on the changes take place, we will classify the chemical reactions into some types. Now let me go for writing one by one. Yes. Now let me go for writing one by one, but I won't give you the names. Names of the types of chemical reactions. You are only going to guess them. For that purpose, I am going to take simple examples. I am going to take very simple examples for the chemical reactions which we have already learned. You are able to tell. The first example, magnesium. Dear students, you all know that when the magnesium burned in the air, what happens? Yes, it reacts with oxygen and produces a white powder called magnesium oxide. Is it not? Equation is not balanced. Just you have to observe that. Let me go for taking another one. Suppose you are going to take a fuel. In the main component of that fuel is carbon. What happens when this fuel is burned? Yes, you are right. Again it reacts with oxygen and produces carbon dioxide. Then one more example which you have learned in 8th standard. Could you tell the name of the non-metal which is yellow in color and it is in powder form? Yes, you are right. This is sulfur. Just recall that what happens when sulfur is burnt in the deflagrating spoon. Yes, the fumes will start coming out. What will be the color of that? Yes, white fumes. How it happens? Because sulfur reacts with oxygen and produces the white fumes, and we call them as sulfur dioxide. Next, one more simple example which is very familiar to us. Hydrogen and oxygen, these two react with each other to produce which compound? Yes, it is water, that is H2O. Is it not? Similarly, I'll go for taking another simple example, that is sodium and chlorine. A chlorine gas is to be passed over sodium metal. Then what is produced? You are right, it is NaCl. Is it not? Then I'll take H2. What is that? Hydrogen and chlorine. These two gases are made to react with each other to form a compound. Can you name that compound? Hydrogen and chlorine. What do you say? Yes, it is hydrogen chloride. Clear? Observe all these examples. Here we have taken two compounds on the reactant side. These two will combine to form how many products? Only single product, right? In every chemical reaction you can see that here two substances undergo chemical reaction or they combine to form a single product. Then could you tell what type of chemical reaction it is? Here the reactants are combining. Yes, you are right. Very good. This is called combination reaction. You are right. Combination reaction. Then could you define this? You can define in this way. A type of a chemical reaction in which two or more chemical substances combine to form single product. Got it? Once I repeat. A chemical reaction in which two or more chemical substances undergo chemical reaction to form a single product is called combination reaction. I am using the word two or more, but here I have given the examples for the chemical equations where only two reactants are there. Maybe more than two also. One simple example which I have learnt in 8th standard. Iron, right? Then it reacts with water as well as oxygen present in the atmosphere and produces, yes, it is Fe3O4. Is it not? H2O. It is rust, hydrated iron oxide. Clear? See that here more than two reactants are there. Now let me go for writing the definition of combination reaction. Once I repeat, a chemical reaction in which two or more substances undergo chemical change to form a single product is called combination reaction. Yes, I'll write it. Here I have written the definition. Go through that. A chemical reaction in which two or more substances combine chemically to form a single product is called combination reaction. Is it not simple definition? And these are some examples. Now here no equation is balanced. You can go for balancing it directly. Mg plus O2 gives rise to MgO. How do you balance it? Here see that an element having maximum number of atoms, it is oxygen. 2 is there. Here only 1. You can write here 2. Oxygen atom is balanced. Then magnesium 2 is there. Here 1. You can go for multiplying 2. Similarly, here also 2 is there. Here carbon 1 is there. 1 carbon, 1 carbon, 2 oxygen atoms, 2 oxygen atoms. Next, third example. S plus O2 gives rise to SO2. It is balanced. H2 plus O2 gives rise to H2O. Observe, 2 atoms of hydrogen, 2 atoms of hydrogen. But oxygen, here is 2, here is 1. Hence, we have to multiply here 2. Now, oxygen atom is balanced. What about hydrogen? 2 2s are 4. But here 2 is there. Hence, you have to multiply here 2. Then, sodium chloride. Look here. Sodium atom is balanced. But chlorine, here 2, here is 1. Hence, we have to multiply 2. Then, 2 atoms of chlorine, 2 atoms of chlorine, 2 atoms of sodium, but here is 1. Hence, you should write 2. Next, hydrogen and chlorine gives rise to hydrogen chloride. Here, 2 atoms of hydrogen, there is only 1. Hence, you can write here 2. Observe, hydrogen is balanced, chlorine 2, chlorine 2. So, this is about the first chemical reaction, that is combination reaction. It can be written in general form as, okay, A is a chemical compound, B is also another one, and these two will combine chemically to form a new compound called AB. Followed? Here I have made a simple chart to understand it about combination reaction. Observe here. Here, 2 reactants combine to form single product. Here 3 reactants combine to form single product. This is the general form. A plus B gives rise to AB, or A plus B plus C gives rise to ABC. Clear? Yes. Please go for copying that. Now we are moving to second one. Here also I am going to take a very simple example. But name of this type of chemical reaction will not be given. You are only going to tell that. Those simple examples are the first one, which is very familiar to you. Here, water is there. H2O is water. Assume that we have taken acidified water. Just recall your previous class concept, I think probably 6th or 7th. Could you tell what happens when electricity is passed into this acidified water? Yes, you are right. It gets split up into hydrogen and oxygen. Is it not? Then similarly, another compound, you are also very familiar with this. AgBr. Name this compound? Yes. Silver bromide. Silver bromide. Here, then can it split up by itself? No. Then is there any condition? Yes. What is that? When it is exposed to the sunlight, what happens? Then it gets split up into silver and bromide. Is it not? Here water, in this case, when the electricity is passed into the water, it gets split up into hydrogen and oxygen. Similarly, I go for another simple example. A piece of chalk. What is the chemical name of that? Yes, it is calcium carbonate. Then chemical formula, it is CaCO3, right? What happens when this calcium carbonate is heated? Yes, it gets split up into calcium oxide and carbon dioxide. Is it not? In the same way, I'll go for taking some more example. That is FeSO4. It is, name this compound, iron sulfate. What is its color? It is pale green. Could you tell what happens when iron sulfate is heated? Yes, we'll get Fe2O3. Then other than that, we will get sulfur dioxide, right? Then sulfur trioxide. Is it not? Now, observe here, in all these cases, in reactant side, how many compounds are there? Only one compound. Product side more than 2 or more than 2, right? That means each compound gets split up into 2 or more compound. Then splitting is nothing but it is decomposing into 2 or more products. Can you tell the name of the type of chemical reaction? Yes, you are right. This is decomposition reaction. Then how do you define decomposition reaction? It is a type of chemical reaction in which a single substance or single reactant gets split up or decomposes into 2 or more new substances with a suitable condition, and this is known as decomposition reaction. Clear? One-sided paper. A chemical reaction in which a single substance gets split up into 2 or more new substances with suitable conditions is known as decomposition reaction. Now let me go for writing the definition of this. Yes, here I have written the definition of decomposition reaction. The definition is a chemical reaction in which a single substance splits up into 2 or more substances with suitable conditions is called decomposition reaction. And these are some examples. I will go for giving you another important example. It is lead nitrate. Can you recall its formula? You are right. It is PbNO3 twice. Right? Then what happens when it is heated? Yes, it gets decomposes into PbO, yellow color some compound. Then brown fumes will start coming out, that is nitrogen dioxide. Then another one, when you go for putting a incense stick, lighted incense stick in that, then it start burning brightly. It is because of the presence of oxygen. So we have separate videos for all this. Let me show you after explaining all the types of chemical reactions. Okay. Now here no equation is balanced. Let us go for balancing them. Here water gets split up into hydrogen and oxygen under what condition? Yes, you are right, by passing electricity. Balance it. Here hydrogen atom is balanced. Two atoms are there. Oxygen, here 2, here is 1. Hence I will multiply it by 2. 2 atoms of oxygen, 2 atoms of oxygen. What about hydrogen? 4 are there. 2 2s are 4. Then here it should be multiplied by 2. Clear? Next, second one. AgBr. When silver bromide is exposed to the atmosphere, that is in the presence of sunlight, it gets decomposes into silver and bromide. Observe it. Silver, it is balanced, but bromide, here 1 atom, here 2, hence I will write here 2. Bromine is balanced. What about silver? 2 are there, hence I will write here 2. Then calcium carbonate, when it is heated, it gets decomposes into calcium oxide and carbon dioxide. Then observe this. Calcium 1 atom, 1 atom. Carbon 1 atom, 1 atom. Oxygen 3. Here 1 plus 2, 3. It is already balanced. Next, iron sulfate. Observe it. Iron 1 is there, here is 2. Oxygen 4 is there, here is 3. Then sulfur 1 is there, here is 1, 2 are there. Then how to balance it? We can go for hit and trial method. Let me explain that. Sulfur, you can observe that it is in 2 compounds. Let us not go for taking. Oxygen, here 1, 2, 3, in 3 compounds. Hence the left one is iron. Iron, here 1, here is 2. Let us go for balancing it. Here 2 is there, here I will write 2. Now 2 atoms of iron, balanced. Sulfur, 2 atoms of sulfur. Here 1, 2, 2. Then oxygen, 2 4s are 8. Here 3 plus 2, 5. 5 plus 3, 8. Yes, it is balanced. Now let's move on to lead nitrate. Very important. When lead nitrate is heated, it decomposes into lead oxide, nitrogen dioxide, and oxygen. Balancing. Lead 1 atom, no problem at all. Then nitrogen 2, but here 1. Then what about oxygen? 2 3s are 6. Here is 1. Here 2, 5 are there. So oxygen it gets split up. Hence, which one we can go for? Yes, when you take nitrogen, 2 is there. If you take 2 here, then 2 atoms of nitrogen, then 4 atoms of oxygen, 4 plus 2 6, 6 plus 1 7, but here is 6, so it is not balanced. By hit and trial method, just we shall go for trying Pb, N and O. This is here 1, nitrogen 2, oxygen 6. Here Pb 1, nitrogen 1, then oxygen here 1 plus 2 plus 2. Pb cannot be taken. Nitrogen, if you go for taking, just we have come to know it's not possible. Hence, let us try to balance this one. See, it's not coming, it's already balanced, no problem at all, but this has not come, right? And here oxygen gets split up. Then we can do one thing like this. This nitrogen, when you multiply 2 here, it has not come. Hence, I'll go for taking 4. If you take here 4, this should be 2. Let us check it out. Here 2 and this is 4, right? Yes. Observe. How many atoms of nitrogen? 4. Here 2 2s are 4. Oxygen 4 2s are 8. Here 2 3s are 6. Sorry, 2 3s are 6, 6 2s are 12. Here 8 is there, here 2, 10. Then I should write here 2. Right? Observe. 2 atoms of lead, 2 atoms of lead. Oxygen count 2, 8, 2, 12. Oxygen count 2 3s are 6 into 2, 12. Next, nitrogen 4. Here 4. Now the equation is balanced. Clear? Now generally it can be written like this. Here I'll go for taking a compound, call it as AB, and it decomposes into 2 or more substances with a suitable condition, whatever the condition may be. Then it gets split up into A and B. Got it? Okay, this is the general form. Now let me show you a chart with respect to decomposition reaction. Observe here. When you observe this chart, you can come to know that here a single compound gets split up into 2 compounds. Here a single substance gets split up into 3 substances. Got it? AB gives rise to A plus B. ABC gives rise to A plus B plus C. Got it? Yes. Now you should go for writing the definition of decomposition reaction from here to here. Then you should take these examples. In all these examples, the equations are balanced. I think in the beginning only you have written this. So you have to leave the gap like this only. Then after that, you have written the first definition and this is second definition. That is second type of chemical reaction. Followed? Yes, please go for copy. Dear students, we are familiar with elements, many elements. As we know, there are 118 elements, but at present we know 115 elements, 115 elements. In that, some are chemically very reactive, some are moderately reactive, some are least reactive. And you have already got the information about the reactivity of these elements in your previous class, particularly in 8th standard. And from that, we have learnt how to arrange the elements in the decreasing order of their reactivity or in the increasing order of their reactivity. What do you call that series? Very good. You are right. It is a reactivity series. reactivity series. Then why it is necessary to know about reactivity series? To learn the third important type of chemical reaction. Then here I told you the elements are to be arranged in the decreasing order. Particularly we will go for taking the metals. So the decreasing order of the arrangement of decreasing order of the metals is called reactivity series. Got it? Then what are those metals? You can recall them, which is the highly reactive metal and stored in kerosene. Yes, you are right. Very good. This is, first one is potassium, and one more metal that is also highly reactive, hence we will go for storing it in kerosene. This is Na, natrium, nothing but sodium. Right? Then next one is calcium, like that. Many are there. Now I am going to show you this metals present in the reactivity series. Here, this is, observe this reactivity series. Here we have written first potassium, next sodium, third one calcium, fourth one magnesium, fifth one aluminium, next zinc. In between that we have written a non-metal called carbon, then iron, lead, next hydrogen, this is also non-metal, then copper, silver, gold. So this is, these metals are arranged in the decreasing order of their reactivity. The arrangement of decreasing order of metals is called reactivity series. Now I am going to write the same metals on the board. Here I have written the definition of reactivity series. See that the arrangement of metals in the decreasing order of their reactivity is called reactivity series. These are the metals. I have already shown you the chart. Now just once you go for recalling the names of these elements. K, potassium, Na, K means it is kalium. Kalium is nothing but potassium. Na, natrium, this is sodium. Ca, calcium. Mg, magnesium. Al, aluminium. C, it is carbon. It is a non-metal, so that I have highlighted that with a box. Zn, zinc. Fe, it is ferrum, and it is iron. Pb, plumbum, nothing but lead. H, hydrogen. Cu, it is cuprum, copper. And Ag, argentum, nothing but silver. Au, aurum, which is gold. Then how to remember these? Yes, for that we can go for taking a simple code to remember these in the order. K, Na, Ca. See that. It is Kanaka. K, Na, Ca. Kanaka. Then Maze. Fe is iron. So that I'll go for taking this as Mazi. See that? Ma, M-A, Z, Z, I here for the sake of remembering purpose I have taken iron as I. Then here PHCAA. Okay, I'll write it as PCAA. You can remember like this. Kanaka, Mazi, PCR. See that? Potassium K, Na, Ca, Ma, Mg. Then A is there, that is aluminium. Then this is Mazi, zinc. Then iron, Zi. Then Pc, it is Pb, nothing but lead. And C, copper. And this is Ag. And this is Au, silver and gold. You can remember like this. Okay, now based on this, now let us go for learning the third type of chemical reaction. Observe this. Here I am going to take a simple example which is very familiar to you, again which I learnt in A standard. The same example is going to be taken here. Look at them. Here I will go for taking iron, and iron nail is taken and it is to be kept in the beaker containing the sky blue color solution. What is that? You are right. This is CuSO4. This activity will also be shown in the video. Got it? You just observe. What happens when iron is kept in the copper sulfate solution? When you observe after some time, you can come to know that there will be brown coating on the iron nail, which I have learnt in previous class. I am making you to recall the same. That brown color coating, it is nothing but Cu. Then this sky blue color solution gets converted into or turned to pale green. What is that? You are right. This is FeSO4. Is it not? Why it has happened so? Observe it. When you observe the reactants and products, you can come to know that in place of Cu, Fe has come. Why? What is the question? What is the reason for that? You know that. You just observe iron and copper in this. Iron is here and copper is here. Could you tell which is more reactive? You are right. Iron is more reactive than copper. Hence, it can takes the position of the copper. Clear? So, iron displaces copper from copper sulfate. Then it becomes iron sulfate. Then copper gets separated. Why copper gets separated? Because it is less reactive, which has been removed by iron. Clear? So, based on this, can you tell what type of chemical equation it is? See, this is the chemical equation in which an element present in the compound is displaced by another element. Why? Because it is more reactive. Here, the less reactive element is being displaced by more reactive element. Therefore, this reaction is called, you are right, very good. It is displacement reaction. Displacement reaction. Once I tell you, a chemical reaction in which an element present in the compound is displaced by another element which is more reactive is called displacement reaction. Now I'll go for taking one more example. Observe it. I'll take FeSO4 plus Cu. Gives rise to, what do you say? Can we write CuSO4? You cannot. Why? You know that iron is stronger than copper. Copper cannot displace iron. Hence, this reaction is not possible. Then if it is so, I'll go for taking one more. It is again iron, then or else I'll take zinc and FeSO4. Then can you tell the products? Yes. It is ZnSO4 plus Fe. Can we write so? Observe here. Here zinc and iron are there. Which is more reactive? Zinc. So zinc can displace iron from iron sulfate. Therefore, we can write it as iron zinc sulfate plus Fe. It is also an example for displacement reaction. Clear now? I go for taking one more example, that is magnesium chloride plus sodium. Is it possible to get the displacement reaction? Observe sodium and magnesium. Which is more reactive? Sodium. Then can sodium displace magnesium? Yes. Observe. Sodium is more reactive than magnesium, hence it displaces magnesium from magnesium chloride and it becomes sodium chloride. Magnesium gets separated. Followed? I'll take one more. KCl plus C. Is it possible? What is it? Yes. Not at all possible. Why? Because calcium is lesser reactive than potassium, or potassium is more reactive than calcium. Hence, potassium cannot be displaced by calcium. Hence, no reaction takes place. Clear? So now I'll go for writing the definition of displacement reaction. Yes, I have written the definition and these are the examples, and here I have taken 3 more examples. You just try to complete that. Yes, what do you say? Pb plus CuCl2. Observe Pb and Cu. Pb and Cu, which is more reactive? Pb is more reactive. Lead is more reactive than copper, hence it can displace copper from copper chloride. Then what will be the compound? It is PbCl2 plus Cu. Fe plus HCl, iron plus HCl, hydrogen chloride or hydrochloric acid. Observe, Fe and H. Iron is more reactive than hydrogen, hence it can displace hydrogen from hydrogen chloride. You will get FeCl2 plus, yes, it is H2. Next, copper oxide plus magnesium. Copper and magnesium. Observe, copper and magnesium is here. Magnesium is more reactive than copper, therefore it can displace copper from copper oxide. It is MgO plus Cu. Clear? Here I'll write. What is the third type of chemical reaction we have learned? It is displacement reaction. Displacement reaction. Got it? Then how do you write its general form? Assume that AB is a compound, and in that one side will be electropositive and another side will be electronegative. Then I am going to take the element C. Then how do you write? You can write it as whether you write AC plus B or BC plus A or CB plus A. Yes, it is. We know that it is electropositive, so that we can write it as CB plus A. Clear? Okay, this is the general form. Now let me go for showing you the chart with respect to displacement reaction. Observe this chart. Look here. Displacement reaction, it is also called single displacement reaction. Here we have a compound, here is an element. If an element is more reactive than an element present in the compound, it can displace easily. Then we get new compound and the element get separated. Here C is more reactive than A, hence it displaces A. We get a new compound called CB, and here is A get separated. AB plus C gives rise to CB plus A. Followed? Okay, now we are moving to the fourth type of chemical reaction. Yes. Before going to fourth one, you have to copy from here. See the reactivity series right up to here, then third one up to here. This information is must for you. You must remember this. This order. Kanaka, Masi, PC, R. Where? See that these are potassium, sodium, calcium. Ma, Ma, that is Mg, magnesium, Al, aluminium. Z, it is zinc. Then it is I is there, Mazi, Zi, Z is zinc, I is iron. Then P is lead and C is copper, and this is Ag and this is Rm, nothing but gold. Copy this. Now we are moving to fourth type of chemical reaction. In this, again I am going to take simple examples which you have learnt in your previous classes. Here I will write HCl and another one is NaOH. Just by observing these only, you can tell that I have taken one hydrochloric acid and second one is sodium hydroxide. And you have also learnt in 7th standard that it is acid and this is base. What is acid-base reaction? It is called neutralization, right? Then if it is neutralization, what will be the products? The products will be salt and water. That is most familiar reaction to us. Now here hydrochloric acid react with sodium hydroxide to produce the salt called sodium chloride, right? And water, it is common. Is it not? Observe here. Could you tell what are the ions present in hydrogen chloride? Yes, you are right. It is H plus and this is Cl minus. Then sodium hydroxide, it is Na plus and OH minus. Is it not? Observe. Then these ions, here in the reaction, these ions, what will happen? You just observe here. They have together formed sodium chloride and H2O. Sodium chloride, it is formed by, see that, Na and Cl, these two ions. And water is formed by hydroxide ion and hydrogen ion. From this, what would you like to say? Here, these two, can we say that these two compounds exchange their ions mutually, right? So, they have formed two new compounds. Is it not? Now, I am going to take another simple example which you have learned in the very first class of this chapter. One is the aqueous solution of PbNO3 twice. Name this, lead nitrate. Then another one, aqueous solution of one more, that is potassium iodide. Yes, tell that. Name the compounds that are formed. These two are colorless. We get the yellow color precipitate. Do you remember that? Yes. This is PbI2, right? Then KNO3. Observe here also you can notice that the ions present in this compound are Pb 2 plus and NO3 minus. What are the ions present in potassium iodide? It is K plus and this is I minus. Here lead iodide is formed by exchange of ions from these two compounds. See the lead and iodide. Next, potassium nitrate is formed by the mutual exchange of ions present in these two compounds. They are potassium and nitrate. Got it? So, in this chemical reaction, we can come to know that the ions present in the compounds exchange mutually to form two new compounds. Then, in general, can we say that here Pb is displaced by K to get KNO3? Is it not? Similarly, I is displaced by NO3 twice. Then we have got PbI2. Displacement is taking place now, but how many times? 2 times. Hence, we can say that it is, you are right, it is double displacement reaction. Here I'll write the name of that. It is double displacement reaction. Double displacement reaction. Once you recall the definition of double displacement reaction. Here, the chemical reaction in which the ions present in the compound are mutually exchanged to form two new compounds is called double displacement reaction. Clear? Here, and we know that this is the salt and it is water. Here, this is precipitate. These two are colorless solution, means these two are aqueous solution. These will react with each other to form a precipitate called lead iodide. What is its color? This is yellow. Then this is the salt. That is aqueous solution of salt. Next, I'll go for taking one more example. Here, this is Na2SO4. Name this. Yes, you are right. This is sodium sulfate. Another one is BaCl2. Can you name this? Barium chloride. These two, we have taken two aqueous solutions. These two will react with each other to form two new compounds. What are those? Very simple. See that? NaCl and BaSO4. Here are right. BaSO4. Right? Then plus NaCl. Clear? And this is white precipitate. Dear students, from this double displacement reaction, we can also come to know one more important thing. That is, precipitate is formed by the reaction between two aqueous solutions, here and here. Got it? Shall I take one more example? Yes, here I'll write one more example. That is, PbNO3 twice plus Na2SO4. Hope that you are only able to tell the name of the compounds that are formed. Yes, you are right. They are. One is PbSO4 plus, we'll write NaNO2. Is it not? NO3. That is lead sulfate, Pb 2 plus, SO4 2 minus. Lead sulfate, then sodium nitrate, Na 1 plus, NO3 nitrate, NO3 1 minus, NaNO3. Clear? Yes, now let me go for writing the definition of it. Here I have written the definition of double displacement reaction. Once you go through that, the chemical reaction in which the reactants exchange mutually their ions to form two new compounds is called DDR, double displacement reaction. And these are the examples. Here just I have written the ions only for the sake of understanding. You can write only this much. If you want, you can go for writing the ions present. Okay, take down these four examples. And before that, here I'll write the general form. Fourth one, this is double displacement reaction. Double displacement reaction. How do you go for writing? I am going to take a compound AB. What are the ions present? One is A plus and another one is B minus, right? Then one more compound, it is CD. You may take X, Y, P, Q, whatever you want. The ions are C plus and D minus. Then could you tell the two new compounds? You can go for like this. See that? It is AD plus. Will you go for writing BC? No, BC is wrong. Then what do you write? It is CB. Understood? Now let me show you the chart with respect to double displacement reaction. Observe. This is the chart of double displacement reaction. Here we have taken two compounds and their ions are represented with different colors. Here in the first compound, red and green ions. Then here in the second compound, blue and brown ions. They mutually exchange their ions to form two new compounds. So we have written AB plus CD gives rise to AD plus CB. This is very important. And here also I have shown the direction how we have to take. See that AD and this is CB. Clear? Hope that you have understood. Now let's move on to another one. Now we are moving to the next type of chemical reaction. Here you can observe that just I have written reactants. Before going to that type of chemical reaction, first let us go for completing this. Then could you tell what is the product obtained by the reaction of magnesium and oxygen? Yes, you are right. It is magnesium oxide. When sodium reacts with oxygen, you will get it is sodium oxide Na2O. Then when sulfur reacts with oxygen, then sulfur dioxide is formed. All are very familiar to us. Then NH3, what do you name this compound? It is ammonia. What happens when ammonia is heated? Yes, you are right. You will get nitrogen and hydrogen gas is liberated. And before going to that, just focus only on this. Dear students, what you can come to know from these chemical equations? Observe, in first one, second one, third one, in all these cases, the elements will react with oxygen, right? Whereas in fourth one, here NH3, it undergoes decomposition to form nitrogen and hydrogen. In this, hydrogen is removed, but in first three cases, oxygen is added. Is it not? So this, the addition of hydrogen to a substance or removal of addition of oxygen to a substance or the removal of hydrogen from a substance in a chemical reaction is called, it is called oxidation reaction. Observe, this is fifth one, oxidation reaction. Oxidation. Observe it. OXI, oxygen. Then IDATION, addition. Here only the meaning is there. Addition of oxygen to a substance in a chemical reaction is called oxidation. Or one more definition, the removal of hydrogen from a substance in a chemical reaction is called oxidation. In bracket, for your reference I am writing like this. It is plus O R and minus H, nothing but addition of oxygen to a substance or removal of hydrogen from a substance is in a chemical reaction is called oxidation. I'll go for writing the definition later. Just keep observing. Even these are also not balanced. Let us go for completing this. Observing. Here sodium reacts with hydrogen to form, tell the compound, it is sodium hydride, NaH, because Na1 plus H1 minus. Next, nitrogen reacts with hydrogen to form ammonia, that is NH3. Clear? So what type of chemical reactions are these two? These are combining to form single product. This is called combination. Observe it. PbNO3 twice. What happens when PbNO3 is heated? We are very familiar. We have already come to know in case of decomposition reaction, lead oxide is formed. Then nitrogen dioxide. The brown color fumes will come out. They are nothing but nitrogen dioxide. Then oxygen gas is released. Right? Then KClO3. This is potassium chloride. Chlorate. On heating potassium chlorate, we get KCl plus O2. Did you understand? Observe the first two. What do you say? Here, can we say that in these two reactions, hydrogen is added? Yes. Then, in these two, look here, PbNO3 twice, oxygen is there. It has been removed from it by heating. KClO3, here also oxygen is there, it has been removed. Then can we say that it is removal of oxygen? Yes. So this addition of hydrogen to a substance or removal of oxygen from a substance is called reduction reaction. Sixth one, it is reduction reaction. Followed here on it. Addition of hydrogen or removal of oxygen. Once I go for repeating the definitions of both. Oxidation reaction. So here the addition of oxygen or removal of hydrogen or addition of oxygen to a substance or removal of hydrogen from a substance is called oxidation. Oxygen addition or hydrogen is removed. Here the addition of hydrogen to a substance or removal of oxygen from a substance is called reduction reaction. So now I'll go for writing the definition. Now please go for writing the definitions of both. It is oxidation reaction and this is reduction reaction. Write the definition and take these examples. Please do remember, whatever the chemical equation you may write, it must be balanced. Here I am not balanced, just a small assignment. When you are writing this, you have to balance them. Okay. Similarly, here also, what are the examples I have given for reduction? And for these also, you can go for balancing them. Right. Now I'll move on to one more time. Before that, pause the video and copy from there to here. Yes. Hope that you have written, and just we had missed a few words. I'm sorry. I have written them here. Addition of oxygen to a substance or the removal of hydrogen from a substance in a chemical reaction. In a chemical reaction is called oxidation reaction. Here also, after writing from a substance, after writing this much, you have to write in a chemical reaction is called reduction reaction. Now just I'll move on to another last type. Subtype of chemical reactions are many. Later we will move on to these one after the other. Now I have been giving the main types of chemical reactions. One more, just keep observing. Here this is CuO plus H2. Could you tell what happens when copper oxide reacts with hydrogen? Here copper gets separated, right? Then we will get water, H2O. These are the products. Please do remember, and this chemical reaction is very important. And you can observe in this chemical reaction whether it is example for oxidation or reduction. You, as soon after observing H2, you can tell that, sir, it is addition of hydrogen, so that it is reduction. But, well, can we say that it is also oxidation? You just keep observing. Here copper oxide is there. Followed. From this copper oxide, oxygen is removed. Right? That has been written here. So what do you call this removal of oxygen? Removal of oxygen is called reduction. Right? And this oxygen is added to water. Then what do you say about addition of oxygen? Addition of oxygen, it is addition of oxygen is oxidation. Oxidation. Then can we say that this is the one of the chemical reaction which includes both reduction and oxidation? Yes. Then what it is called? Okay. I am going to take red from reduction, red, and OX, ox from oxidation, and the new chemical reaction, this is called reduction reaction, redox reaction. This is 7th one. The chemical reaction in which both oxidation and reduction take place simultaneously is called redox reaction. Let me go for taking another example. This will be the last example for in today's class. It is H2S plus Cl2 gives rise to. Could you tell that? Yes, you can say that. Here S get separated and hydrogen will react with chlorine to form hydrogen chloride. If you want to balance it, here 2 atoms of chlorine, 2 atoms of hydrogen. Here only 1 atom is there, hence I'll write here 2. You can count it. 2 atoms of hydrogen and 2 atoms of chlorine. Clear? Now, let me go for explaining this. Here also you can identify which is oxidation and which is reduction. Dear students, you just observe this one, and here just a small correction. This is oxygen is removed, so copper gets remained. Then here, in this example, you can come to know that hydrogen is removed. Then when hydrogen is removed from hydrogen sulfide, it gets reduced to sulfur, right? So this is a removal of hydrogen. What do you call the removal of hydrogen? Yes, Removal of hydrogen, it is nothing but oxidation. Is it not? Oxidation, removal of hydrogen, minus H. Now, and this hydrogen is added to chlorine, then we will get HCl. Got it? So then here we can say that addition of hydrogen, and we can call addition of hydrogen is known as reduction. Therefore, we can say that this is an example for the chemical reaction in which both oxidation and reduction take place. Hence, it is called redox reaction. Now, let me go for writing the definition of redox reaction. You have to copy that one. Dear students, here I have written the definition of redox reaction. Observe this. The chemical reaction in which both oxidation and reduction take place simultaneously is called redox reaction. Here I have taken two examples. The first one is here copper oxide reacts with hydrogen to produce copper and water. Look here. Here oxygen is present in copper oxide. So this oxygen has been removed. By removing oxygen, copper oxide gets reduced to copper. So this removal of oxygen is called reduction. Then the removed oxygen is added to hydrogen. When oxygen is added to hydrogen, then hydrogen gets oxidized, then becomes water. So this is addition of oxygen and is called oxidation. Clear? So both are there. And second example, observe here. Hydrogen sulfide reacts with chlorine to form sulfur and hydrogen chloride. Here hydrogen is present in hydrogen sulfide. So this hydrogen has been removed. By removing, hydrogen sulfide gets reduced to sulfur. So this removal of hydrogen is called what it is? Oxidation. Next, so this removed hydrogen is added to chlorine. Then chlorine takes the hydrogen and becomes hydrogen chloride. That is why we have written here addition of hydrogen, which is called reduction. In this examples also, we can see both oxidation and reduction. Hence, these two are examples for redox reaction. Dear students, hope that you have understood all the 5 types of chemical reactions. So, first one is combination, second one is decomposition, third one is displacement, fourth one is double displacement, fifth one is redox reaction. Redox reaction. And to explain redox reaction, I have used both reduction and oxidation, and both are written separately. So now let me show you the chart which shows all the 5 types of chemical reactions. This is the chart in which all the 5 types of chemical reactions are there. Combination, decomposition, displacement, nothing but single displacement. Next one, double displacement. And fifth one is redox reaction. Okay, dear students, today we have completely focused on types of chemical reactions, and all the chemical reactions are very important. Please do practice them today itself without keeping anything pending. Okay, and we can continue. We can continue this chapter in the next class. So with this, let us stop the class. Thank you very much.